All right, let's look at the 2014 AP or AB free response question number 3. This was a non-calculator question, but honestly, the calculator is not going to help you anyway, even if you want to use it. You have a graph of F. Pay attention, this is the graph of F. It consists of 3 line segments, and then they tell you that G is this function. And anytime I see an integral defined function like this, I will almost always, especially in the case of a free response question, I will immediately find the derivative of that integral defined function because it is so easy and quick. We're going from constant to variable. To do the derivative of this, you simply plug the x in everywhere you see a t, and so there's only one, it's f of t, and then you always want to be mindful that you multiply by the derivative of what you substituted in the place of the t. So in this case, I plugged in x in the place of t, which means I need to multiply by the derivative of x, which would be 1. So that step is okay if you forgot to do it this time. However, they do on occasion ask questions where it's like -3 to x squared, in which case you would plug x squared in and then multiply by a 2x. So always be mindful of that derivative of what you substituted, the chain rule application. A is to find g of 3, so don't get too excited about the g prime thing. This is g, not g prime. And g of 3, my first step is going to be some elementary algebra, where g of x is the integral from -3 to x. So g of 3 would be the integral from -3 to 3. And so we do that first little algebraic step. And then we run into the calculus. You have to understand that that is a question of area. And so our job is to find the area under f from -3 to 3. -3 starts here. We cross the x-axis at 2, and then right here is 3. So I'm going to find the area of this triangle, which has a base of 1, 2, 3, 4, 5. So half of 5, and the height of that triangle is 4. Plus, and then this little triangle right here at 3, we have negative area. We have a negative accumulation here. So I'm going to do a -1/2. The base of that triangle is 1. And then for the height, I need this y coordinate. It appears to be 2, but let's be sure. This point is the ordered pair 2, 0. And so if I go from 2, 0 to 4, -4, that would be a slope of -2. And so the slope of -2 does mean that I'll go down 2 over 1. And so that is a height of 2. And I think I'm going to do something a little bit different. I'm changing my mind on how I'm going to tackle that negative. It is a triangle. And so I'm going to do plus half the base of the triangle, which was 1, went from 2 to 3. And I'm going to say the height of that triangle is -2. And so I'm going to put the negative over there because that's really where the negative is coming from. I would stop there. You do not have to simplify that. It doesn't ask you to interpret this in any way. However, for those of you who did go a few steps further, that would be half of 20, which is 10, and half of -2 is -1, which gives you a final answer of 9 for g of 3. Okay, so now I'm looking at B. On what intervals is the graph of G? Pay attention, it is asking about G, not F. So when is G increasing and concave down? So increasing means G prime is positive. Concave down is G double prime is negative. And that's kind of going to be the reason for the answer. We'll need to somehow tie it to F because that's the graph that we're interpreting. So G prime is positive. And G prime is positive when F is positive, because way up here, I made the connection that G prime is F. So G increases when G prime, which is F, is greater than 0. And this occurs on the intervals. So when F is positive, that happens from -5. We do have an instant when F prime is 0 at -3. However, F, not F prime. We do have an instant where G prime, because F is G prime, is 0 at -3. However, because the derivative is positive on both sides, we can blow straight through that and say that this occurs on the interval -5 all the way to 2. And then G double prime is going to be the same thing as f prime. And so if f prime is negative, that means that f is decreasing. Okay, so that's going to be my other thought process. See if I can scroll this up a little bit. There we go. There. Okay. So now G is concave down. When G double prime, which is F prime, is negative, this is when F is decreasing, which is on the intervals F decreases from -5 to 3, and then again from 0 all the way to 4. And now we are looking for where G is increasing and concave down. So that's going to be the intersection of these intervals. And so we're looking for where F is positive, so that's above the x-axis, and decreasing at the same time. So the places where F is positive and decreasing are these windows right here. Okay, so therefore, now I can say that G is increasing and concave down on the intervals -5 to -3, and then again from 0 to 2. And there's your final answer, and we have kind of taken care of the explanation and the reasoning for that before we gave the answer. So on to part C. Where do I put this? Where do I put my head? I'll put it down here. All right, so we are given a function h, and they ask for h prime of 3. Because this is non-calculator, we must write down what h prime of x is first. And even if this was a calculator question, you would have to write down the derivative anyway, because this unknown g equation prevents you from plugging it straight into the calculator. So quotient rule, low d high minus high d low over low, which is 5x squared. Okay, so that means that h prime of 3 is going to be 5 times 3, which is 15. G prime of 3 minus G of 3 times 5, all over 5 times 3 squared. And now I need G prime and I need G. A long time ago, we made the connection that G prime is the same thing as F. So this graph of F is G prime. And at 3, we already established, and this is in previous work, but we did establish that this is the ordered pair, 3, -2. So the answer is going to be 15 times -2 minus G of 3. We actually solved that in part A. So G of 3, if I hadn't already simplified the problem, this is when I would work it down to the final numeric answer of 9, because I need to use it in part C. So G of 3 was 9 times 5, all over 15 squared. And I would not try to clean that up. I would leave it exactly like that. However, for you overachievers who chose to simplify it, 15 times -2 is -30. 9 times 5 is -45. 15 squared is 225. So we have -75 over 225, which is a third. That's -1/3, I believe. 25. Yeah, I'm almost positive that's -1/3, and I don't feel like verifying that. But I would, if I were you, stop with this answer in blue. There's no need to simplify it because they didn't ask you to interpret this. If they did ask you to interpret h prime of 3, that you found the derivative, you would simply determine if this is positive or negative to know if the function h is increasing or decreasing. However, they didn't ask for any interpretation, so leave in that blue answer. All right. So another function P is this function. Find the slope of the line tangent at the point where x equals 1. So in other words, find P prime of -1. And just like the previous problem, I'm first going to have to find P prime of x, which is a chain rule. We'll do the derivative of f. We'll leave the inside alone times the derivative of the inside, 2x minus 1. And then P prime of -1 is going to be f prime of -1 squared, which is 1, minus a -1. And then 2 times negative 1 minus 1. So that's f prime of 2 times negative 3. F prime of 2, we are looking at the graph of f. This is where you have to be very careful that you lock into what this graph represents. F prime of 2 would be the slope, and the slope right here is negative 2. So the slope at that point is negative 2. So this will be negative 2 times negative 3. And typically I would stop there. However, this is fairly easy to clean up to a nice simple 6. And there is the end of this question.